In this lecture, we're going to show the calculation of a 3D frame of beams. So in the previous chapter, we talked about the truss elements. In this chapter, we're going to talk about the beam elements, and we're going to show what is the difference between the beam and truss elements. So beam element is also 1D element, but beam elements can carry end loads, shear forces, and torsion, while the truss elements can only carry end loads. The cross-section of the object treated as a beam can be constant or can be tapered. While we had with the truss element, when you have an object and we treat that object as a truss element, the cross-section can be only constant. Some examples, we have some constructions as we see shaft, legs, coupling links, pipe-like assemblies, and so on. We can create an object that will be treated as a beam element by using boss extrude, loft, weldments. As well, the ratio of the length and the depth of your cross-section has to be bigger than 10. Now let's talk about analysis setup. So when we create a mesh, we can have arbitrary numbers of elements per body, and we can increase those numbers of elements and we can decrease. While with truss elements, we had only one element per body. As well, joints can be rigid or hinged, while with truss elements, we only have rigid joints. Constraints can be only at joints, as well as with the truss elements, and the loads can be applied at the joints, can be applied at defined points, points that we define, and loads can be distributed along section. While with the truss elements, we can only have loads at joints. So now let's make a quick summary, beam versus truss. So as we said, the ratio between the length and the depth has to be bigger than 10, and then we can treat that object as a beam. Cross-section at a beam can be constant or tapered, while with the truss, the cross-section can be only constant. Beam elements can resist to axial, bending, and torsional loads, while the truss elements can only resist to axial loads. As well, when you treat object as a beam, we can apply loads at joints, points, and we can distribute load along section. While when you treat object as a truss, we can only apply loads at joints. Regarding the mesh, with the beam elements, we can create arbitrary elements per body, and we can use apply mesh control. While we have a truss, then we only have one element per body. As well, when you have a beam element, then every joint at the beginning and end of the element can be controlled. With the trusses, we can control joints. So we can make a joint hinged, rigid, and so on. And we will show that on the real example. And now we're going to show in the quick example the difference between beam and truss.